All right, this is lab 3 for logic circuits. This is called logic simplification. And in this case, we're going to do logic simplification using Karnaugh maps. Okay? So what we're going to do is we're going to start with this logic equation here. And so it's fairly complicated, or maybe not that complicated, but we have a complicated logic circuit. We want to simplify it down. And then again, this is all to get rid of certain gates so that we can make the cost of the circuit cheaper, right? So we start with this, this logic circuit here, okay? And the first thing we need to do is come up with the truth table for this circuit, okay? So now this is the way you do it, okay? Okay, right, so there's all of our different permutations of inputs. Okay, and when you see a logic equation like this, it's real easy to figure out what the truth table is, right? Because here's the thing, these three terms are ORed together. So whichever one of, if any one of these terms yields a 1, you get a 1 in your truth table. Otherwise, you get a 0. Right? So all I do is I look at the equation and I say, okay, what's going to yield a 1? This term here, if it's 0, 0, 0, right, that gives me a 1, 0. This one, if it's 1, 0, 1, okay, that gives me a 1. Now in this case, right, you could have either A could be 1 or 0, it doesn't matter. Right? So you're going to have two 1s coming from this term. Okay? So we look at this and we can say 0, 1, 0. 0, 1, 0 is a 1. And 1, 1, 0 is a 1. Okay? And then the rest are zeros. Okay, so there we've got our truth table. Okay, so now we want to set up our Karnaugh map. And we can group these things differently, it doesn't really matter. I usually do it like this, right? So I say A, B, and then C. So this is 0 and 1. Right, so it's 0, 0, 0, 1. The next one is 1, 1. You can only change one of these bits at a time. Right? So I can't do 0 or 1, 0. So it has to be 1, 1, and then 1, 0. Okay? That's just the way it is. Okay? And now what we want to do is transfer these 1s over to our Karnaugh map. Okay? So here we have our first 1 is right here, right? So 0, 0, 0. Okay? Now the next one over here, this is 0, 1, 0. Well, that's a 1 as well. Okay. Then we have 1, 1, 0. Oh, that's a 1 as well. And then where's our other one that's missing? That's this guy here. And that's 1, 0, 1. Right? So that comes over here. Okay. So now we've populated our Karnaugh map. And now what we want to do is group these things together. Okay, so you have one grouping here like this, and then a second grouping like that. Okay? So now what I do, and again, this is my personal way of doing things, right? Is we are going to write the equation for this. Okay? So this is, so this first grouping, this is grouping number 1 here. And then we'll say this is grouping number 2. So number 1, right? This is A bar, B bar, C bar, or with A bar, B, C bar. Okay? So what ends up happening, right, is we have these terms here. We can pull out A bar, C bar, and then we can have B or B bar. Right? And then B or with B bar cancels out. Right? Because that's always a 1. And then 1, so that just disappears. So you're left with A bar, C bar. Okay? So let's do number 2. Okay? So this is A bar, B, C bar, or with, this is going to be A, B, C bar. Okay? So, what can we factor out of this? Oh, no, sorry, that's A. Oh, no, that's right. Okay, sorry. So what we factor out, B, C bar, and then A, or with A bar. Okay? And again, this term goes. Okay? So what we see here, this is B, C bar. Well, that's that. Right? This had already been somewhat simplified. Okay? So what we've done is, when we do our groupings, we found this one simplification that was already done. Okay? So then, in our case here now, for this one, what essentially we've done is we've taken this part and we've eliminated the B bar. So the actual simplified instruction is, or equation is going to look like this. Okay, A bar, C bar, or with A, B bar, C, or with B, C bar. Okay, so we didn't simplify it all that much, right? But we did go through the process on how this Karnoff map works, right? So again, I wanted to show you how my process of how to do the Karnoff map. Okay? And so now what we do is in the lab demonstration part, right? We're going to design this circuit, or this, for this logic equation, the first one, and we'll test the truth table. And then we'll do this one basically by just taking this B, if we tie it high, or we tie it together with the C bar or the A bar, depending on which one, that makes that logic input disappear. Okay, and then we'll be left with this, and we'll do this test again, and what we should find out is it's exactly the same. All right? Okay? So I will meet you in the lab, and we'll go through our demonstration. Karnoff map, logic simplification lab. I've got the circuit hooked up, and I'm about to go through the logic permutations of the truth table and come up with our output for our truth table. Now, remember that when I'm doing this test, A is going to be the one that goes 010101, right? That's the least significant bit, right? So if you have your truth table ABC and then your output, you may have to switch it around. You know, it depends how you number do all your numbering in your truth table, right? So A is the least significant bit. It's going to be 010101. B is 00110011. And then C is going to be 0001111. All right? And then if you have that numbering, you should get the proper output in your truth table. Okay? So here we are right now. So what I've got, so instead of putting inverters in, basically I'm using all of the 6 bits here, right? So logic bit 0 is going to be A. Logic bit 1 is going to be A bar, B, B bar, C, C bar, okay? So every time I make a change,
I have to make two changes, right? Because if A goes to 1, then A bar has to go to 0. All right? So right now, I've got A, B, and C. They're all 0. And if I measure, I get a 1 out. Okay? And now if I change A to 1, we get a 0 out. If we put B to 1 and A back to 0, we get a 1. Okay? And now we're going to have A and B both at 1, and we get a 1. Now we change C to 1, and the other guy's back to 0, and we get a 0. Then we change A to 1, we get a 1. We change the B to 1, A back to 0, we get a 0. And then we have them all at 1, we get a 0. Okay, now that's right. Okay, so now what I'm going to do, I'm going to change these all back to 0. And what I need to do is make my logic simplification now. And essentially what I need to do is I have to either tie A bar to the B bar, right? We want to get rid of the B bar, right? So there's two ways of doing that. You can jumper two together, or normally what I do is I tie the B to high, right? Because if I AND anything with 1, I get whatever else is left, right? So that's what I'm going to do. Okay, just a second here. Okay, so now we'll go through the permutations again, and we'll see what happens. It should give us the same, right? So this is 0, 0, 0 now. We should get a 1. 0, 0, 1. I get a 0. 0, 1, 0. I get a 1. 0, 1, 1. I get a 1. Okay, so this is 1, 0, 0. I get a 0. 1, 0, 1. I get a 1. 1, 1, 0. I get a 0. And then 1, 1, 1. I get a 0. Okay, so they're the same, right? So our logic simplification, no matter how small the change was, it's still simplified it by eliminating one little bit out of the circuit, right? So again, this is more to focus on the logic simplification, the Karnoff map, versus being any kind of a big logic simplification. All right? Okay, so that's the end of Lab 3. So I'll see you next week for Lab 4. Okay?